Alright, now that we have our hexagon, regular hexagon inscribed in a circle, we're going to connect the vertices with the center, like this. And we're going to study this triangle that are formed by connecting the center with each one of the vertices. You can see that we have 1, 2, 3, 4, 5, 6 triangles that are equilaterals. Okay, for example, let's consider this triangle OPQ here. Let's study a little bit this one. So in this triangle, I'm going to do the perpendicular to PQ, to this chord PQ, from the center, something like this. There you go. This is a perpendicular from the center to the chord PQ, and you know that any radius that is perpendicular to a chord bisects the chord PQ. That means that this is the midpoint of PQ, and this segment PM equals this segment MQ. Now all these triangles, OPQ, are equilateral, so this angle here is going to be how much? 60 degrees. This is going to be 60 and this is going to be 60. Now if I see this triangle OMQ, this is a triangle that has one angle 60 degrees, this one is 90 degrees. How much is going to be the last one? It's going to be 30. This is going to be 30. So I have a triangle OMQ that is going to be at 60 degrees. In triangle OMQ, this side OQ is going to be the radius, okay? All this side PQ is going to be the radius, and MQ is half of it. It's going to be the radius over 2. And remember that in a 30, 60, 90 degrees special triangle, if the small leg is R over 2, the radius over 2, then the hypotenuse is going to be double, meaning R. How do I find out the size of this height here? This height is going to be the small leg, R over 2, times a square root of 3. So OM is going to be R a square root of 3 over 2. Now in order to find the area of the whole hexagon, I have to find, if I find the area of this triangle, one of these 6 triangles, and I multiply it by 6, then I'm going to have the total area of this hexagon. Well, this is easy because the area of this triangle, area of triangle POQ, of this triangle, equals 1/2 of the base times the height. The base is going to PQ, it's going to be PQ, that is R, times the height, that is going to be this one, R square root of 3 over 2, times R square root of 3 over 2. Alright? So R times R is R squared times the square root of 3 over 4. And this is going to be the area of one of the triangles. One triangle. Now the area of the whole hexagon is going to be 6 times the area of this triangle. It's going to be 6 times this area, R squared square root of 3 over 4. If I simplify, the hexagon area is going to be 6 divided by 2 is 3, R squared square root of 3 over, and 4 divided by 2 is 2. So it's going to be 3/2 of R squared, the radius is square times square root of 3. This is the total area of my regular hexagon inscribed in a circle, center O and radius R.